Good morning, 8th graders. Today is going to be our first video lesson. You're not going to see me on the video. Miss Lovely has something going on with her eye, so my right eye is almost swollen shut, so it would be a bit of a distraction on the video. So I'm just going to video the lesson. Before you continue with the video, you want to make sure that you have the 5.1c paper that I put into your folders. It has a note on the top that this is the activity for the video. So make sure you grab that. You might need to pause the video to do that. I'm going to start with going through and reminding us what we have done so far. And we've done some work around what is a function. And the definition that we had been working with is that a function means that for every input, there is only one output. Okay, so that was the definition that we had been working with. And then remembering, well, what is this idea of an input and an output? Remember that an input is the same as our independent variable. And if we recall working with that both in math and science, that's usually talking about our variable x. And then our output is our dependent variable. And that was always referring to the variable y. Now we did work on some graphs to decide by looking at the graph, was it a function? And so today we're going to look at other ways of representing something as a function. So we're going to start with the idea of looking at tables, because we use tables a lot to create our graphs, so we should be able to tell through a table if it's a function or not. So if I create this table, of my input-output values, and let's see if I put 1, 2, 4, 7, and then 3, 4, 8, and 9. So just by looking at this table, I'm going to ask myself, does every input only have one output? So does it only have one value that it goes to? And if that's true, that every x value only goes to one y value, then I would say, check, that's a function. It's following that idea that I have that every input has an output. If your table looked like this, okay, very similar idea, but now I have two of the same values on the x, 3. Okay, so notice how my input, I'm showing that same input twice, but it's going to two different values. That would be giving me an idea of, well, this input is not going to only one output, it's technically going to two outputs. So this would not be considered a function. Okay, you can't have the same x value or the same independent variable going to two different dependent variables or two different y values. So this is how we would see it looking at tables. But then there's this idea called mapping, which is kind of a new idea for you guys, but you're going to see that it's very similar to a table. It just looks like a couple of ovals instead. So if this is my, if I can spell here. If that's my input map, And then now this becomes my output map, okay? If I look at this same idea, if I put 1, 2, and 3 in, and say my outputs are A, B, C, if each of these goes to a different value, we have a function. So each input was going to one output. So that would show us that we have a function there. But if we did that same idea and you got something like this. So these are still my input values and these are my output. If this happened, this input of 2 is now going to 2 different outputs. So that would not be considered a function, because that means that when I put 2 in, I have no idea what I'm going to get for a solution. I could either get B or I could get C. The whole idea of whether it's a function means that I can predict with certainty what I'm going to get. When I put something into that function, I'm going to know exactly what I get out of it. But here, if I put in a 2, there's 2 different options that could happen. So I don't know exactly what's going to happen. Okay? So let's look at 5.1c. Let's look at this first problem here. Okay, so we're given the information of 4 different stages. And let's go through and fill out the tables. So stage 1 has 2 smiley faces. Stage 2 has 4. Stage 3 has 8. And stage 4 has 16. So just by looking at this, can you see that every input has only one output value? And the same thing if we mapped it here. These were our stages, very similar to a table. These were our outputs. And each input would only have one output. And then you could plot these values on our graph. And remember we talked about that vertical line test. So if I was to draw lines up and down, would I only have one point on those lines? If I had more than one point, then that would fail my function test. And then your ordered pairs, you know how to write your ordered pairs from the table. So my first ordered pair would be 1, 2. My second ordered pair would be 2, 4, 3, 8, and 4, 16. And remember that our ordered pair are X and Y. So we can still see that for every input, there's only one output. Okay, if you need to pause because you need to finish filling that, make sure you pause the video so you're filling out all your information. Okay, we're going to look at a couple examples together. So if we looked at number 2 here, and it says the input is the age, so here's our input, and our output is the shoe size. And it wants to know if it's a function. So we need to ask ourselves, for each of these inputs, is there only one output? And we would say no, there's multiple outputs. So no, and we would say each age has more than one shoe size. Okay? So don't just tell me each input has only one output. Relate it to the story. In this story, we're talking about age and shoe size. And number 3 says that your input is your number of chairs, and your output is the number of legs. So if I have 1 chair, I'm only ever going to have 4 legs. If I have 2 chairs, I'm only ever going to have 8 legs. So does every input of a chair have only 1 output of legs? Yes. So we would say yes. Number of chairs has only 1 number of legs. Okay. And then they want you to list your ordered pairs from up here. So if we look at the top here, we had 13 went with 6. And then 13 also went to 7. And 13 went to 8. 13 went to 9. 14 went to 7. 14 went to 8. And 14 went to 9. So there you can see in your ordered pairs, there's 4 different things you can get when you put 13 in for X. There's 3 different things you can get when you put 14 in for Y. Okay, I think that should be a good start for you. What you need to do now is in your schedules, you were told which group you're in. So if you were in group 1, you were told on the next set you need to do problems 8 through 13. If you're group 2, you need to choose 9 of the problems from the front and back. If you're group 3, you need to choose 10 problems from front and back. And then you need to email me your work by tomorrow, because I will be collecting that to look over to make sure that we're understanding what a function looks like in different ways to represent it. If you have a question, send me an email and I can either email you back, or if you want me to call you and we can talk through it, we can do that. But you have all that work, and just make sure you're following along with your schedule, and I will be touching base with all of you tomorrow. So I hope you guys have a great day, and make sure you check in with me if you have questions. Bye.